All right. Good afternoon. Thank you for taking the time to listen to my talk. I know that you're all getting fairly hungry and ready for a lunch. I'm Evan Schultz. I work at Wrangle.io. And for those of you that are attending the camp tomorrow, and part of your swag, there's going to be a cloth for cleaning your glasses. And on that, there's going to be a QR code that you can use to enter in a Pebble watch. Anyways, enough about that. On to building Angular 2 applications with Redux. So kind of in a typical kind of complex single-page application, there's a lot of moving parts, and kind of everything is connected to everything else. It's very rare that you have a piece of data in isolation that's only being used in one spot. And this kind of results in that kind of everything is connected to everything else. And changing anything in one spot tends to either break something else elsewhere in your application. So some of the solutions that we know of now to help solve these problems is moving towards a component-based UI, and this is really evident in Angular 2 with the component-based approach. Also using a unidirectional data flow with the flux pattern, and also trying to take a stateless approach deeper within your stack. So kind of next, I'm going to talk a bit about the benefits of taking a stateless approach to your apps. So first off, there's probably lots of us here that were kind of like born and raised with a very object-oriented mindset of developing a software. And kind of one of the challenges with this is that objects tend to be stateful. And what this means is that the effect of calling a method depends not only on the arguments that you pass in, but the state of the object itself. The result of this is that these can start to become very hard to test, because to do accurate tests, you have to try and mock that internal state. The end result is that things start to get harder to understand. You're not always sure of how this object got into that state. And this is because we're aiming to mimic the real world, which does not always translate to our applications. So kind of why are we bothering to try and replicate this complexity? So the alternative approach is to try and use pure functions. And the idea with that is a pure function, the results of it depend only on the inputs into it. So if you pass in A and B, you'll always get the same result out. There's no, say, external state that this function is being dependent on. Pure functions also don't have any side effects within your system, so you don't have to worry about affecting state elsewhere in your application. And this means that pure functions have no state within themselves, and this leads to kind of much easier to understand code, because you're looking at a function, you see the inputs and the outputs, is really obvious what's going on. Makes it really easy to attest, and this also allows you to kind of build up much more complex systems by composing these smaller stateless functions. And these patterns are kind of widely used on the server side right now. It's not necessarily a new idea. It just seems like with the front-end world and how our applications are getting more and more complex, these patterns are starting to be relevant to front-end developers now. So how does state become painful in an application? And this is kind of, say, for your traditional like MVC approach, is you have a component that's talking to a model, and your component will get or update your model. Your model will update itself, and then your component will reflect that change. And in a small-scale application, it works fairly well. However, the problem starts to arise when you have a few more components, a few more models, and then you have multiple components that need information from one model, and then components that require other models, and eventually you kind of end up with this spider web of dependencies where different models are updating different components are requiring things from different models, and it gets to be really hard to understand what's happening in your application and why. So kind of one of the patterns that's been a bit more popular with React and getting a lot more traction in Angular recently is a one-way data flow with Flux. And Flux itself isn't really a library. It's just a design pattern where you have this one-way flow of data throughout your application, where your component will talk with the action creator. Your action creator will go and talk with your APIs and whatnot, and then dispatch an action to your dispatcher, which then updates your stores. And then basically you have this central source of truth that all of your components will then read from. And the only way to modify your state or your store is by dispatching actions. And this gives us a much more predictable flow in our applications. So Flux on its own is pretty good. And then the idea is, can we do things better? And the answer to that is getting more stateless with a library called Redux. And Redux is a library that is only concerned with managing the state of your application. It can be used with React, Angular 1, Angular 2, Vanilla.js. Its only care is about managing state in your application. And the key concept is having a single store or source of truth that is managed by reducers. And you might be wondering, can a single store be a good idea? And also, if you're not used to more functional programming concepts, you might be wondering, what is a reducer? So first, I'm going to go over a basic reduce function, because this is kind of the building blocks of a Redux application. So what we have here is a add one value that takes in the value that you want to add, and then the current state. And what it does, it will iterate over the array and keep adding one. And the end result is basically a sum function. And as basic as this looks in terms of the concept, it's such a fundamental building block and very powerful because the output of the reduce does not need to match the shape of the inputs. And this is where we get into the how we approach action reducers in Redux. And what we're doing here is we take in an action, a state, and return a new state. Your app state is basically a reduction over all of the actions that you've passed in. And each reducer operates on a subset of a global state. When I was first reading into Redux, I thought, oh, you have one global state. I was imagining this 10,000 line file that's managing the state of your application. But there's ways to kind of break these out into smaller and smaller pieces and compose them up into a larger global state. So you're able to combine reducers into a larger and more complex one. So for example, this is a lineup reducer for a sample app that hopefully I'll have time to show. And this is just kind of managing people joining or leaving a lineup. And as you can see here, basically you pass in a state, you also pass in an action, and then there's a switch statement to see which actions that we're doing. And one of the key things here is that we're trying to not mutate the current state, but always say return a new copy if we're modifying it. And the end result of this is testing is very easy, because since the result of the reducer is solely dependent on what you've passed in, doing unit testing on your reducers is extremely easy. And also, if you have errors, it's easy to mock out the state where the error happened, pass in the action, recreate that error, and try and get your test passing. So why is this a good idea? As your reducers are pure functions, they're easy to understand and easy to test. They're synchronous, so you don't have to deal with trying to mock promises and asynchronous behavior. This allows you to also separate your data logic from your view logic. Kind of think of your reducers as kind of like the database of your application. And then you can still have modularity by having smaller reducers that are concerned with one area of your application. And this also opens up new opportunities for tools. There's lots of really great dev tools for Redux that hopefully I'll have a chance to show closer to the end. So with Redux, though, the idea is that you should not mutate state, but every time that you want to update the state of your application is return a new object with the new values, not the same object with the updated values. And basically, what we have to do is introduce a immutable data structure, there's a few ways of approaching this. There's object.freeze, which will do a shallow freeze on your objects. There's a library called seamless immutable that will freeze the entire object for you. But in every application, you do have to update things based on actions happening. So how do we do this? This is where we get into kind of having a derived immutable. And since you can't change the object itself, what you have to do is create a new object with those changes. One of the libraries that I've been using a lot lately is Immutable.js. It's a library made by Facebook that kind of gives you a number of immutable data structures and a really great API for kind of being able to update and insert things into your state. And one of the very nice things with Immutable.js is that it will reuse the same objects if you haven't modified them. So if you have like a big list of items, you update one of them. With the list that is returned, it will only create a new object for the things that you have touched. And this is kind of a key building block for a stateless application. And this also works really well with the change detection features in Angular 2. Because Angular 2 has introduced this idea of on push, where the change detection will only trigger if a reference to the inputs have changed. So instead of having to kind of do this like property by property checking if you're passing in an object, it'll just check to see, is the reference being passed in the same to the one that I'm holding on to now? And if used correctly, it can have a pretty big performance impact on your application. So now that I've gone over a bit about the basics of Redux, I'm going to be talking now about how to use Angular 2 with Redux with a library that I've been working on called NG2 Redux. So with NG2 Redux, it's kind of Angular 2 bindings for Redux, and the goal of the library is to make working with Redux feel as natural as possible within an Angular 2 application. You can find it on GitHub, npm install ng2 Redux. And some of the features that it has is that your store becomes an injectable service. You can also expose the store or slices of state as an observable. And it's also compatible with the existing Redux ecosystem. Redux has been around for a year or two. It's been really popular with React, but there's kind of an entire ecosystem of middleware and tooling that NG2 Redux is compatible with. And if you want to see kind of all the awesome tools that can be used with Redux, you can follow that link there. So to get started with an Angular 2 application, the first step is to kind of bootstrap your application with the ng Redux service. So you import ng Redux and then do the bootstrapping like you would in any other application. The other step that we have to do is start to configure our store. So we have a series of reducers that are being responsible for various slices of state within the application. And with Redux, you can use the combined reducers to form these up into one larger state object. So you don't have to worry about having this one massive, like 10,000 line file that's managing the entire state of your application. You can split things down into like smaller and smaller areas of concern. Once you have your store configured, and the root component of your application is where you kind of do the configure store. You provide the reducer that you want to use. You can also provide an initial state if you have one, and also apply any middlewares or enhancers that you want to have. I don't have time to go into like the in-depth of what middleware and enhancers are, but middleware in short is basically every action that gets dispatched will go through all of your middleware before hitting your store. And that enables things like logging. You can use it for an API layer. There's a lot of flexibility that can happen there. So once you have your application kind of configured to be using Redux, there's this concept of like having a DOM component or a presentational one. And the responsibilities of a DOM component is basically it will receive data from a smart component or a container using a input. And it will emit events upwards towards the parent with outputs. And its main responsibility is for rendering only. It doesn't know how to access state, it doesn't know how to modify state, and it doesn't know how to dispatch actions. It's pretty dumb in that basically it's only relying on what you've passed in and the things that they emit up, which allows these to be highly reusable throughout your application. So kind of what, say, the backend class of a dumb component might look like is you have your @component definition. We load in our template. We tell it that we're going to be using the on-push change detection strategy. And this is all that our lineup class needs. It's basically defining our input and the events that we're emitting. There's nothing else going on here. And our template for it, all we're doing is iterating over the inputs that have been passed in, displaying some information, and then when you click on the button, we emit an event upwards. And this is all that it's doing. And at this point, it's pretty dumb. And there's not much use here until you put it within a container or a smart component. So with the container components, this is where they know about Redux. They're responsible for getting the data from the store. They're responsible for passing the appropriate data down to the dumb components, and also responsible for kind of dispatching and handling actions. And also, you can kind of nest somewhere appropriate, because you don't want to have one massive container that's doing absolutely everything within your application. So wherever it's appropriate, you can kind of create new containers that will encapsulate an area of concern. So the template for it is pretty straightforward. We're making use of the lineup that we had before, and we're passing in the lineup as the lineup property, and we're also handling the events for party joined and party left. The backend class for it, we're injecting our NG Redux service, and we also have an action service that is responsible for handling our actions. So whenever an event is emitted upwards, we're then dispatching an action that will modify the state of the application. This also allows us to kind of keep our container classes fairly light and thin, and then we want to push most of our logic out into services, reducers, and our action creators. And those will become easier to test also. So the next part is, how do we actually access the state of our application? So there's one way with using ng-redux.select where you can pass in either a key name, a function, and also these are returning observables. So if you're using RxJs and know how to use observables, you can do things like map, combine with, combine latest, and you get a lot of flexibility by being able to expose parts of your state as an observable. And if you want to reduce a bit of your boilerplate, we also have a @select decorator, which has like the same API as the .select method, where this is, I think, reduces a lot of the boilerplate in your code compared to having to use the ng init and doing the .select there. The next part is being able to actually dispatch actions. So there's ng-redux.dispatch. This will also work with any of the middleware that you have. And you can either do a dispatch from the component itself, or a pattern that I've been finding works a bit cleaner with Angular 2 is a action service pattern. And the final action that is dispatched that will be sent to your reducers has to be a plain JSON object. So an example of dispatching from a component, you might import a plain function from a file, and then in your component do ng-redux.dispatch and fire off your action creator. However, the challenge with doing things this way is that within your action creator, you lose access to Angular 2's dependency injection. And this is usually one of the first questions that I get asked when people are starting with Redux is, how can I access my Angular services? So the pattern that I prefer is kind of, say, the action service pattern, where you create an injectable class that is meant to be dispatching your actions. You can access your other Angular 2 services. So if you've built out your API layer, you can have access to that. You can also inject ng-redux and have access to its store methods like subscribe, get state, dispatch, etc. And if you're doing a synchronous action, it's pretty straightforward. All you have to do is dispatch and then provide a JSON object that is the action that you want to fire. If you want to handle an asynchronous action, this is also fairly easy with NG2 Redux. But the pattern that we tend to use is we call an action creator that initiates the request, and it notifies everyone that this action is about to happen. This could be useful if you want to have like a loading spinner or anything like that. Then once the action completes, you then dispatch an action saying that success or failed. And you can also put the details of making the request into its own module. And the idea here is basically the final action that is dispatched to the store is kind of the event that actually happened, not what you want to happen. So an example of the code for doing an asynchronous action is the first thing that we're doing is dispatching an action that we're like trying to join a party. We then call a service that we have that this might be dealing with a asynchronous HTTP request. Once that resolves with our next party ID, we can then dispatch an action saying party joined with the payload of our party ID, number of people, and party name. And if things failed, we can dispatch an error saying, well, something went wrong. So to take a bit of a look at what this functionality looks like in an actual application is I've created a small app called Trendy Brunch that manages kind of a simple kind of restaurant where people can join a party. And my screen is a little cramped right now. And what we can do is now these dropdowns here are being driven on what's going on here. And then let's say once I see the party, it's instantly removed from here, and then it's no longer available to be selected there. And instead of having to do this, like say, pub sub of saying, oh, this party has joined, all we're doing is subscribing to changes in state. We don't have to deal with like pub sub and passing messages around. We just have this observable stream that everything else is receiving the data from. And then let's say I see the party and start an order. As you can see, kind of like as I increase how many bowls of fruit that this one table is ordering, the available stock here is going down. And you can kind of complete the order and then start to modify it down here also. And as you can see, as I say modify information down here also, this is the data here starts to update to reflect. And this is all just based on observing and transforming these slices of state. However, the really cool thing is this works with the Redux dev tools. There is a Chrome extension for it. So one of the bits of tooling that I was talking about before, one is the logger. And the very cool thing with this is you can see every action that is firing off in your system. If you drill down into the action, you can kind of see what the previous state of your application was, what the dispatched action was, and what the resulting state was of your application. This becomes very handy for trying to debug problems in your application. However, you can also use the Redux dev tools and start to kind of get a history of every action that's been fired, and start to kind of say rewind things, and even start to kind of turn back time. And you can start to have that, say, time travel debugging within your application. This is incredibly handy for trying to debug and test applications. And another great feature is that, let's say we want to, is you can also import and export the state and history of your applications. So for example, I was playing around before with a different state. I can load it up. And I can now start to kind of step backwards through the history of this application and see what was happening right back to the absolute start. So if you're working with like a QA or a tester, and like, oh, I was working on this feature, it blew up and started to act weird, they can export the state as a JSON, and then you can import it into your application and start to replay their actions and see what happened and where things fall apart. And that state can then also be used in your unit test. You can like copy that JSON, have that be the state that you pass into your unit test, and try and fix that issue. A other very handy thing, for example, is if you add, say, the debug session query string to your application, what it will do is start to kind of keep track of your state between page loads. So I'm just going to load up my demo state again. And complete this order. And let's see down here, if I increase this too much, this number is really weird, and we want to format it better. If we want to go and just make a quick fix to have it display better, instead of having to go through and do all those actions again to end up back in the state, it's just going to reload the application and then put it back into the state that you were before, and you now have that change applied. You don't have to go through and do all that clicking manually yourself, which makes this a really nice kind of developer workflow. So that is the end of the demo. I'm going to switch back to. So basically, the demo is called Trendy Brunch. It's online at GitHub at github.com/e-schultz/ng2 camp example. And some of the, say, caveats of using Redux is basically it's addictive. You won't be happy using anything else. Once I started to use Redux about a year ago, any other way I tried to build applications just feels weird. Your friends might not understand your obsession, because I've been kind of obsessed with this for the last year or two. It's kind of awesome. So thank you. And yeah, that's all.